In the next and last example, survey town, we are going to continue the idea of a simple artificial example, but this one, taken from the book by Foreman, was actually slightly more involved. What you see is actually a town where all the streets are named after statisticians, especially survey statisticians. And the town is divided into blocks. And those blocks, for example, take block number 4, has 1, 2, 3, 4, 5, 6 plots on which, or lots on which I could build, but actually on only 4 of them is there really a building. So we have 2 variables, 2 survey variables, x being the number of building lots and y the number of houses on those. Evidently, for every unit is x smaller than y, because you cannot have, in this example, more buildings than there are lots, because it's actually the other way around, sorry. So you can not have 2 buildings on the same lot. That's the way it's defined here. So this relationship must hold. There are 8 units. The variable y is easy to remember because it's just the unit. The number of houses in block 5 is 5. The number of houses in block 7 is 7. But the number of lots, as there is progressively more and more empty lots, that increases more rapidly, although tightly linked, of course, that's what we observe, to the number of houses. The population totals are chosen such as to simplify the algebra a little bit. If we add the x's, so we sum all those numbers, you can do the exercise and you get to a total of 50. Which means that the average would be 50 divided by 8. The sum of the first 8 numbers is 36, 8 times 9 divided by 2, which means that the average is 36 divided by 8. So these are the numbers. 50 divided by 8 is 6.25. 36 divided by 8 is 4.5. And then the population variances can be calculated in this way. Exercise, verify that with the numbers from the previous page, go to the algebra at least once, and you will get to, respectively, for x, 10.5 almost, and for y, 5.25. So, look, it's possible for a variable like x and y to be not so different in terms of average, but being fairly different in terms of population variance. Okay. Because we have 2 variables, the concept of proportion comes on the table very easily, very naturally. So we could define the number of builded upon lots, or we could define the proportion of building lots on which there is a building, and that's 72%. 36 divided by 50 is 0.70, 0.72, or 72%. Now you can also get to that in a different way. You can define Zi to be 1 if a lot is built upon and 0 if the lot is empty. So for all of the 50 lots, Z is 0 or 1, which means that the average of Z is the average of numbers between 0 and 1, which must lie between 0 and 1, and guess what? That's 72. Now, there is something fundamentally different with before. Xi, there I range from 1 to 8. Yi, I ranges from 1 to 8. Zi, I ranges from 1 to 50, because we have changed the unit. On x and y, the units are block, and there are 8 blocks. On Z, the units are lots, not blocks, and there are 50 of those. So, in a way, this lends itself naturally to multi-stage sampling. I can sample blocks, and then a block sample can further be subsampled to produce a number, but not all of the lots on that territory. So it's very natural, conclusion, it's very natural to have in the same sample units at different levels, at the block level and at the lot level in this case. At the town level, the household level, the individual level in the Belgian Health Interview Survey. Right, let's do a little excursion and now calculate the population variance, but that's relatively easy to do. So we go by the definition and we say, let I cycle through all of the 50 units, and for each of them, calculate Zi minus the average, 72, and square that. So the average squared difference. But then we say, wait a minute, Z, unlike X and Y, can take only two values. Either it's 1 or it's 0. How many ones are there? It's 36. So there are 36 buildings, so 36 times is the contribution 1 minus 0.72. The remaining 50 minus 36 is 14 times, it's 0 minus 0.72. And now divide by 50, because I'm dividing by 50 anyway. So bring this together and also here. Then you get 36 divided by 50 and 14 divided by 50. But wait a minute, 36 divided by 50, that's 0.72 also. And 14 divided by 50 is therefore 1 minus 0.72. All right, but look at that now. Look where we are. We have two terms, and each of them consists of 0.72 multiplied by 1 minus 0.72. But there is a little left over because one of the factors is squared and here the other factor is squared. So if we do that, we bring up front what is common to the two factors, 72, 1 minus 0.72, and we put in square brackets the remaining terms, 1 minus 0.72 plus 0.72, this is just 1 and vanishes. So what we get is 0.72 times 1 minus 0.72, or r times 1 minus r, or pi times 1 minus pi, the familiar Bernoulli variance. Okay. Now, that brings me to the end of 1312, and then from now on we are equipped to start doing some further population level and then later sample level calculations.